What's that? Okay. Oh, okay. How's this? Better? Well, I'll just stand closer. So, welcome back from lunch, everybody. My name is Samir Khan. This is my third Pi Texas talk. I think I've been to all of them except one, which was at my own university, UT. And I know some people around here use a different permutation of those, all the other permutations of those initials. So, by the way, this talk is already online at dfwpython.org. If anybody wants to follow along under the presentation section, they can do that. And having been to dfwpython.org, Dallas Fort Worth, dfwpython.org. And under the presentation section on the left side, there'll be a sidebar. So having been to, all the Pi Texas conferences, which have always been at a university setting, I just wanted to tailor it more toward both the, professional audience, people who have 20 years of experience maybe, and also people who are in school and maybe just have a couple of years. And the reason why I think that this might be of help to people who have more experience is that I think these features are a little bit underutilized, and I'll go into why perhaps they can be used more and why they might be of benefit to everybody. So to begin with, a quote by one of the pioneers of our field, and this is a famous quote which you can throw at anybody who, at a code review or something, they say, wow, this is not very efficient, so you can point out to them what somebody as a luminary as famous as Donald Knuth at Stanford pointed out would be, the root of all evil. And he himself has later attributed it to another guy, Tony Hoare, who invented quicksort, and again, a very famous, one of the pioneers of our field, who used to visit Texas a lot when Edsger Dijkstra was at UT, and he came here many times and gave presentations. So, and this was their consensus. And to me, the amazing thing about this quote is that this was said at a time when, computing resources were just, even the Apollo, Saturn V rocket, the amount of computing power on that thing was, well, at least by the time it got to the moon, was so minute that, most people's, phones, the newer 3G, 4G phones have more computing horsepower available. So, so it's kind of, points out why, just necessarily measuring CPU cycles and getting hung up on that is not always the best approach. And this becomes even more, with how, nowadays, with the cloud and the Intel Developer Forum just a few days ago, they said Intel expects by 2020 computing to be so cheap that it will be basically, meaningful computing will be by their, somewhat marketing enhanced projection, more or less free. It will be just, taken for granted. And so, but at the same time, that costs and are falling down, and resources are just so plentiful. You can get 64 gig EC2 instance if you need to do some specific, simulation or something in half an hour. And things are available now which were just, unthinkable even 5, 6 years ago. So, but the problem is at the same time, the complexity of code bases and the size of code bases keeps increasing. And even within Texas, I know there are companies that 5, 6 years ago, their Python code base was a few 100,000 lines of code. By now, it's in the millions. And really, if you are land in one of these projects, then how do you come up to speed? That's why you can use some of these techniques, tracing and profiling, not just for performance analysis, but to gain a comprehension of what's going on as well. And the concept actually is wider than just, programming language traceability or profiling. It can be used in many other areas in which you can, you have a call flowing through a cell phone system. You can trace it based on its whatever the unique ID is, which in most cases happens to be the phone number, or you can do it based on your session ID as HTTP messages arrive at your server and how they are passed through the different layers of the system. And so, I mean, the idea of tracing is actually somewhat higher level, but we can get it more or less, without any extra effort in our code, and I hope to show that it should be used more. So why do I feel that it's not as used as often as well, I mean one would like to see it used? And really that was brought home to me when I first discovered that option set-x or set-vx within the shell script world of KSH, and now bash, everybody uses bash. And this basically turns on tracing, and you can set like your PS4 environment variable, like PS1 through 4 and all that, and you can literally follow line by line how a shell script is executing. Somebody throws a 500-line script at you and says, debug this. Well, like, I mean, you just do set-vx at the top of it, or some function that you feel might be misbehaving just within that, and you can start seeing what exactly how it's running. We have that capability in other languages too, like, I mean, the C, C++ languages. Java has its own profilers, but gprof is kind of considered the, standard for, industrial strength computing. Well, I mean, the open source standard. I mean, there are commercial alternatives as well. But again, there's a huge amount of, I mean, people wrote some tool for their own specific needs, and it's just sitting out there on GitHub or somewhere, and it might not have been updated for a long time, and it might be difficult to get it to work because it relies on some libraries, some specific version of libraries. So it's not always very easy to get these to work. And even some of the commercial tools, again, they also have a reputation for being hard, and I mean, to decipher their output. And so to me, the thing was, how can we get that KSH or bash type functionality very easily without jumping through hoops, installing some huge amount of libraries and some tool, and changing your code base just to get it to work with those libraries and things like that. So those are some of the reasons why I think it hasn't been used as much. But if you discover some of these Python, well, I mean, some of the easier ways of profiling, then I hope more people will start using them, profiling and tracing. So right off the bat, we get within our batteries as included approach of Python the trace.py module or library, which basically has both a command line and a programmatic interface, and you can just right off the bat, without changing a line of code in your code base, if you need to see how exactly a subprogram is running, you can start it with basically the options, so it'll show the line on which it's executing, what are the contents of that line, and things like that. And it also has a programmatic interface in which you can, I mean, fine-tune it based on your parameters. This will obviously have some effect in terms of performance, but on the whole, I mean, for programs that are not doing very heavy lifting, it works fine. So again, it's just without changing a line of code, you get traceability. But it's, fairly basic, nothing very fancy. What you really want is the sys.settrace, which is much more powerful in terms of the things in which it can introspect at runtime, and you can really fine-tune what you want to see printed and things like that. So basically, you just write your own function, which will be a callback, and you just pass it to sys.settrace. It starts basically looking at different events. And so it will be called either before a function call, well, if you're looking for the line events, then it'll be called for every line that gets executed. Before before each line that gets executed, or before they return from a function. And it can also be triggered if an exception is thrown, then you can check that as well. And within your, the callback function, you can set for or you can search for whatever type of event you want to have and only do it, run it then. And you can even search for, based on the under arguments, the function name and things. So basically, if you are only interested in a certain type of function name, then you can test within the callback method that, am I being called for this function with this name? Only then you can run your own debug code. So sys.settrace is much more preferable to the trace module, but I mean the trace module just has command line interface, and you can do a very quick and dirty profile tracing run with that. Then we also have the profiler, which is usually, you may have noticed that my talk is entitled Tracing and Profiling, and for understandability, tracing is actually good enough. But a lot of people still consider profiling to be much more, meaningful information that it provides in terms of where is my code actually spending time. There is obviously a very heavy, probe effect with this. Anytime you start profiling, then, there's going to be overhead. And that's why this is written in C. There is actually a regular pure Python version of profile as well, which if you, for some reason, if you still need to use it. In fact, there's another version thing called Hotshot, which I don't know if it's still included or not, but used to be included with the standard library. But C profile is, has the same interface as profile, but it is several orders of magnitude faster because it's written in C. So you can just, run it with whatever your program is, pass it its arguments, and it will run it, and it will show the, the output. The output is not always in terms of how much time of CPU was spent in this function versus that function, and what type of, the times that, things took to complete. But the output is not always very pretty, so it can also be, formatted nicer with p-stats, and you can get that, again, included with the standard library. You can sort it by CPU or memory or whatnot. So again, that profiler is also not bad, but it's purely function-based. So you find out, okay, so it's spending this much time in a function, but if the function has, 500 lines, then it's where's the bottleneck? That can be hard to figure out. So we have something called line profiler as well, available in PyPy. So this does not come with the standard library. And this shows, this is again written in C, Python, and this shows the time that each line takes to execute. So it kind of is, it provides both profiling and tracing. So you can follow the logic of your program and figure out how much time it's spending on each line, which is very critical, especially if you are basically your own code may be working fine, but it is the library call or it is the database call, which is where 98% of the time of execution is actually spent. So if you have a big function, you may find out that, yeah, well, it's that function, but which particular line is it? And which line was the bottleneck with our particular set of data, which is something, again, that people need to consider anytime you're using profiling tools, that your data set affects what type of data you get. So you need to set up the experiment correctly in terms of the big O, notation, and different sizes of n input and things like that, and whatever, constitutes your, standard data set. So, it's possible to, compare apples with oranges and arrive at conclusions which may be good enough for marketing people, but for, real technical people, they want to, control the experiments and make sure that they are comparing the right sides. Different sets of results that they're comparing come from similar sets of runs. So, and the nice thing about this is that, well, another nice thing is that it's written by a guy named Robert Kern, who works at Nthought in Austin. So this is something software which was written in Texas. So that's another reason to hopefully consider it, and definitely a powerful tool. It helped me find some interesting problems with something I was trying to debug, and it turned out to be SQLite, which was the database, the database insertion. And, in a large piece of code, figuring out which particular call is the culprit in terms of time of execution, and then you can basically, figure out that, okay, I need to change the algorithm. And that is, kind of the bigger takeaway from profiling, that it's not so much a question, given especially that resources are becoming so cheap that you're trying to, wring every last CPU cycle out and, get your money's worth with that. It's really a question of getting a feel for, where are the hotspots, where are the things which are in your regular, if you're not going to go to the distance of, setting up an experiment and all of that, what are the things that you can improve, and what are the things where optimization may make a difference, especially if you have large data sets. So basically, as opposed to, getting hung up on like, this thing takes 67.5% of the time, and that one took 62.3% of the time, or anything like that. Those debates are possible, but the idea is just to get a ballpark figure and to understand that, there is going to be a probe effect. So without the profiler, it would certainly have run faster. And again, you can get into all kinds of debates, but those are, not very useful in the real world if your expectations are realistic. It requires a decorator that you can basically, just within your code, if there's some function that you want to check, you just put to the, current prof, I think it's a @profile decorator, and then you can, invoke it from the command line, and that will basically decorate that function to show line information for each line. Which means that if you have code which is, just sitting out there as under main, then that won't be captured in that. So that's another good reason to, get as much out of under main and put it in a function, and then you can profile it with the line profiler. So these are basically some links, and again, you can download it. And the best kind of from Stack Overflow, also the consensus was for sys.settrace. The best tutorial is by a guy named Andrew Dalke. His site is Dalke Scientific or something like that. And he goes through the whole, basically how to set a sys.settrace. And Doug Hellmann has a very good piece on tracing as well as profiling. And line profiler Robert Kern has written stuff. So these should be working links. And yeah, you should be able to get to these. And unfortunately, I'm not using my own laptop. We had some issues with the DVI, digital output. So I have a EC2 instance set up on which I can give demos of this. If anybody's interested, I can do them in lightning talks or anywhere. Like if you want, even you can stop me in the hallway and I can do a demo of whichever one you want. And otherwise, open for Q&A. Line profiler is really good in terms of, the regular profiler is just, function calls, and it's, relatively high level. But, so maybe it wouldn't be a bad idea to also, kind of drill down into the problem that you're trying to diagnose, to start out with the regular profiler, C profiler. So maybe you are working on a system on which you can't even install something using, easy install from PyPy, to get that information, and then maybe, somehow get line profiler there as well, very easy to install. Basically through easy install also. And then to try to profile that particular method which you feel is the place where the bottleneck lies. And, again, to reiterate, sure, performance issues are one thing, but perhaps one other better use for just the profiling tools is just increasing one's own comprehension, especially if you inherit some large code base. Then what is the basically flow of logic through your that code. How many people here have actually used profilers before? Oh, well, okay. How useful did they find them, or just wondering? Or does anybody actually use it on an ongoing basis? Because in the last few years, testability has become a mantra in which everybody has to do testing. And in fact, some of these things the Ned Batchelor, he has written coverage.py, which covers the line. Coverage of your, very similar actually to the regular trace module. But it also serves as the backend for Nose, the plugin for your testing, and you can also do basically coverage analysis of your test cases as well. So I really feel that, traceability and testability is something which also needs some more pushing in terms of testing is fine, but I mean, you may find out that, there are large sections of the code base, especially with large teams working across multiple, time zones, sometimes across overseas and things like that, that there are things that because of some changes, you later found out that this is now dead code, but nobody had realized that, things like that. So really, I mean, it's a powerful tool to use in many ways, and you can actually build more powerful tools based on what's already available. So that's why I kind of concentrated on the batteries included or very simple, easy to install, modules. But you can go on ASP and Cookbook. They are really neat recipes for, doing decorator-based, tracing, profiling. Stack Overflow also, you can combine tracing with logging. There's a very nice recipe that somebody put out, so you can literally, get logging and tracing working together. And these are kind of building blocks through which you can build really powerful tools. But just to get started, we already have the right tools, and we don't need any, huge, gprof run. Then it creates its own output file in which you need to feed to something else. And the GUI tools, which they all have screenshots how it's supposed to look, but most of them, honestly, I couldn't get them to work. Like WX Python, it requires this version. And like in one case, I literally came to the conclusion that I would need to get like the Ubuntu version from 2008 on which the libraries that it was working with, and some of those changes by now literally, won't even work. But, command line is good enough for people like me, so. Uh, that's an interesting question. Yeah. I mean, it is possible, but I've also seen some people sometimes, again, get too wrapped around the axle over minor changes across, different releases. That okay, in this case, it was taking, 82% of time, whatever, and now it's changed, by a few percentage points. But that may be overkill. But over time, perhaps, if we graph it, over significant period of time, then I think we'll get better feel for, where are the things that are, changing, or where is if the memory use is growing up. By the way, I mainly emphasize CPU type and line oriented, output, but you can do memory profiling as well, which is more tricky in Python, given that, everything is dynamic. You can add attributes and those things. Again, if you approach them with the mindset that this is going to be a ballpark figure, and if you use it just for, diagnosing things like, just unbounded memory leaks and things like that, it's good. But to, try to say that I'm going to n digits of precision, and based on this run, I can now make that, say that this is a very accurate, like a precise instrument, that it's not. So. Any other questions or comments? Alrighty. So yeah, anybody wants to see a demo, I have it set up. You can watch over my shoulder, but unfortunately, this is just a PDF file, so I couldn't get access.
What are you using, Django, or what are you using?
It's just, sample programs, just output in terms of, how the line output appears, and, very simple programs. And like I said, this applies to students as well. So there's a very nice one for, how do you teach somebody recursion? So you can literally, go through the, you can show them that, okay, this is the same method that's getting called with these line numbers and things like that. So,
Best practice of keeping your tracing and your debugging utilities out of production while enabling them in development?
Yeah, that's again, one of those very kind of questions. Basically, everybody's trying to get a good answer for that. But unfortunately, you can use things like maybe class decorators to just disable them at a global level when you're about to ship code out, things like that. And I mean, there are other tools, there are other approaches as well, but really, I mean, you'll have to roll your own and figure out what would be the best way. And most of them are not very pretty, a little bit hacky. But during development, you can turn this on to get more information. And but some of this, applies also to production systems. Without changing any code, you can still get good information. All right. Thanks for your time.